Hello and welcome to the demo presentation of our project LEAF, an IoT system for monitoring indoor air quality and conditions. Even though air pollution is a problem that significantly affects our everyday life, it is too often unnoticed. Significant evidence shows that poor air quality is connected to the death of 5 million people a year, of which 1.6 million specifically due to the condition of air indoors. Moreover, air quality, temperature and humidity have been connected to thermal comfort, sleep quality, transmission of viruses and condensation in buildings. The purpose of our LEAF IoT platform is to easily provide awareness of air conditions. The platform measures in real time air quality index, humidity and temperature indoors and makes them available to the users through a Telegram bot, providing also periodic statistics, warnings, tips and rewards. Users are able to combine multiple platforms for different rooms of the house and register multiple accounts, making the system modular and adaptable. We developed the system using a microservices architecture that integrates code run locally with external services like TeamSpeak, Telegram, Grafana, and Grok and the Weather API. Besides AQI, temperature and humidity sensors, our platform has a LED and a small screen as a user interface. On the back end, multiple catalogs provide registration of services, resources, clients, and profiles, allowing a modular design in which sensors can easily connect and disconnect. A broker handles data coming in from the sensors, and the various adapters communicate with the related external services. Multiple analytics services compute statistics about the data and handle responses such as Telegram alerts and LED warnings.
Let's start the video demonstration showing how our system actually works. First of all, we need to set some basic configurations, in particular the IP addresses of some built-in services. We can use this script and specify the service with the corresponding flag referring to the service catalog, the MQTT broker, Grafana and Grok. Then each service relies on a specific configuration file as shown here, with the basic information. We can see, for example, that the service catalog address has been set accordingly. We can individually edit this kind of JSON file to set the IP address and the port on which running the process. This is crucial to have a fully distributed system in which each service can potentially run on a different machine. Then we can launch the service with the command or the specific run script. The main service is the service catalog, since it is in charge of managing the registration of all the services in the system. The client's catalog instead stores the information of the produced and available platforms, as well as the information of the future users that will be registered on our system, so that we can link platforms and users. The profiles catalog stores the preferences associated to each platform and room, including names and parameters thresholds. The character of the catalog is the resource catalog, which is crucial to take track of all the IoT devices connected to the system, as sensor, display, and so on. When we run the process, we can see that each service performs the registration using the put HTTP command, and the others will retrieve the information using a GET request. While we are running the previously described elements, we can also launch our Telegram bot on a different shell and introducing the other services and functionalities present in our system, starting from the database adapter, which is a middleman between the system and the true database. In this case, we have implemented TeamSpeak, but the choice can obviously be changed in the future without any problems, since the presence of the adapter. Similarly, we have developed a Grafana adapter for the user dashboard. Concerning the data analysis and user awareness support, time period-based statistics are available with the corresponding service, and in parallel, we have created a tips database for providing customized suggestions according to the detected conditions. Talking about the smart monitoring tasks, we can introduce the available control strategies. The first one consists in alerting and rewards notifications the Telegram bot. It is an MQTT subscriber, and when one value is detected outside the desired threshold, it checks for the last hour average value to understand if the specific room has been exposed to poor conditions. Clearly, limitations are present to avoid sending continuously the same notification. When the value comes back to normal on the last hour average, the user will be notified too. The LED commander instead is used to have a quick and less intrusive response. The hardware kit can include LEDs associated to specific parameters, which will be switched on when the corresponding value is outside the threshold.
Moving to the user interface, we have developed a Telegram bot to handle and manage our system. Once started, the first required task is to register a new user through the linked HTML form. Once inserted the required data and the unique ID of the platform, the registration is complete. An instance is saved in the client and in the profile catalog, and we can go back to the bot. Now we can log in with the new credentials and access the registered platform. We can use the settings to customize and manage our platform. An important feature allows to create the instance of a new room to be associated to the platform. On the Raspberry, we first associate the physical room to the virtual one created in the bot. In this way, we can know the associated room ID. Eventually, we can run the display, the LED, and the sensors for the air quality. Sensors will ping the resource catalog periodically, sending live messages, while publishing the collected data using MQTT. Now we can access the room data in the bot and visualize the current conditions. Through the room settings, we can change the warning thresholds for each measured parameter based on the user needs and on the suggested optimal values. We can then visualize statistics on different intervals of measured data, including useful considerations on the general air quality trends. Through the Analytics menu, we can also access the room dashboard on the personal Grafana page associated to the platform. The collected data are presented in graphs and panels with which the user can interact. From the main menu, it is also possible to set the location of the platform by sending the current position or inserting a city name. In this way, the nearest available weather station is selected, and outdoor weather data from the Weather API can be displayed. We can also visualize the general status of the system with the associated rooms and the corresponding devices. General tips on how to improve the indoor air quality can also be displayed. Eventually, we can add and manage new rooms and have a complete overview of our system. A warning symbol alerts us on possible critical conditions in the room. If these conditions persist, a notification is received, including a useful tip on how to improve the situation. Another important notification is received if a sensor has been inactive for some time and it has therefore been removed from the catalog.
We would like to thank you for your attention.